What's going on, everybody? Got another video here for you. All right, so we're going to find this limit here. All right, so let's see what we have here. So let's just look at each piece separately. Let's look at cotangent x, and let's look at 1 over x separately. So let's just come over here to the side. So we know cotangent x, and this isn't really part of the work. This is just to show you something. Is cosine x over sine x. And we see that, let's do 2 pi, 3 pi over 2, and pi over 2. And we know sine looks like this. And we know cosine looks like this. Okay. All right, so we are approaching 0 from the right. So we're coming into 0 from the right-hand side. And can you see as we come into 0 from the right-hand side that cosine is pretty much 1? It's not going to really, it's going to be 0.99999, which is pretty much 1. But look at sine. Sine is getting smaller and smaller. Sine is going to 0. Okay, so you're going to have numbers like 1 over 0.01, 1 over 0.000000001. And so that's just getting bigger. So we can see that cotangent is going to infinity. And then as we approach 0 from the right, this 1 over x, as x goes to 0 from the right, that means the denominator is getting smaller and smaller and smaller, so the whole fraction is getting larger. It's going to 0 also. So we got infinity minus infinity is equal to 0. And if you put that on your test, you're probably not going to get any points for the problem. I know if you were in my class, if the problem was worth 10 points, I'd take off 15. Okay, so don't do that. But it's good to know that we do have an indeterminate form. We've got infinity minus infinity, which hopefully we know by now is not 0. Now, the answer to the problem may be 0, but it's not because it's infinity minus infinity. So what we want to do here is we want to rewrite this in here. So this is the limit as x goes to 0 from the right of cosine x over sine x minus 1 over x. And we want to get a common denominator. So if we get a common denominator, that's going to be x sine x, x sine x. So this is going to be x cosine x minus sine x. And that's going to give us the limit as x goes to 0 from the right of x cosine x minus sine x over x sine x. All right. So we get that after we find the common denominator and combine the two fractions. All right, so let's see what would happen if we plug the 0 in. I'm going to come down below and do it. So we plug the 0 in. That's 0 times cosine 0 minus sine 0 over 0 times sine 0. And we can see that this is 0 minus 0 over 0. So we get 0 over 0. So that tells us we can apply L'Hopital's rule. All right. So let's see what we get. So this is going to be the limit as x goes to 0, approaches 0 from the right. So let's do the derivative of the numerator over the derivative of the denominator. So the derivative of x times cosine x, that's going to be product rule. So that's derivative of x is 1 times cosine x plus x times the derivative of cosine x, which is negative sine x. Okay, that's the derivative of this first term, minus the derivative of sine x, which is cosine x, all over the derivative of the denominator. And that is going to be 1 times sine x, we've got to use the product rule, plus x times the derivative of sine x, which is cosine x. And so this is going to give us the limit as x goes to 0 from the right. And you can see here that cosine x minus cosine x, that goes out, that's just 0. So that's going to be negative x sine x over sine x plus x times cosine x. All right. Now let's plug the 0 in. So if we plug the 0 in, that's going to give us negative 0 times sine of 0 over sine of 0 plus 0 times cosine 0. So this is just 0 in the numerator. Oh, and look at this, we get 0 in the denominator again. So what to do? Well, let's apply L'Hopital's rule again. All right, so we've got the limit as x goes to 0 from the right of negative. Now, I'm going to leave the negative out here. I'm going to find the derivative of this. So that's going to be 1 times sine x plus x times cosine x. All right, that's the derivative of the numerator. I had to use the product rule. And then derivative of sine is cosine, and then that's going to be plus 1 times cosine x plus x times negative sine x. All right, so let's simplify this sum. So we get limit as x goes to 0 from the right of negative sine x minus x cosine x over, all right, so look at this, cosine x plus cosine x is 2 cosine x minus x sine x. All right, now let's plug the 0 in. Negative sine of 0 minus 0 times cosine of 0 over 2 times cosine 0 minus 0 times sine of 0. So this is going to be negative 0 minus 0 over 2 times 1 minus 0, which that's just going to be 0 over 2, which is 0. So if you were working this problem and you had your homework was online and you came up here and you said infinity minus infinity is 0, plug that into the homework thing, it would have told you correct answer. But if you would have done infinity minus infinity on a test and put equals 0, you wouldn't have gotten any credit for the problem. Okay, you got to work it like this. All right, so you just, if you did infinity minus infinity is 0, you just got lucky. All right, so I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.